Oh no. There we go. Got it.
Some human beings. So I'll introduce myself. I'm Kyle with Digitalis Education Solutions and the Pacific Planetarium. Digitalis, we make planetariums, large planetariums, and also portable planetariums, and now virtual planetariums. Our test planetarium here in the Pacific Northwest is the Pacific Planetarium. So that's who's sponsoring the show tonight. And I'm joined by my very good friend Ian, who's over, well, it depends on which way your camera is looking.
Hello. My name is Ian Gray. I am a planetarian and work with the Frontiers of Flight Museum down in Dallas, Texas. We have some really cool stuff like the Apollo 7 capsule and the only publicly viewable moon rock in North Texas. So we've got a bunch of really cool stuff, and it has been my privilege and honor to have been working with Kyle for quite a while. He's actually the one who trained me in how to work these portable systems a while ago.
I think I met Ian when he was 16, and he's an amazing planetarian. If you come to any of our shows, I'm sure Ian does this same thing as well. We try to do things live and interactive so you can ask questions. And I realize on Zoom, it's difficult to ask questions. So I'm going to give you permission to do something here. If you were in my planetarium, you could just say, "Hey, Kyle," and I would say something like, "Hey, what?" Right? So open up the chat, and I want you just to practice. Just type in the chat and literally say, "Hey, Kyle," or "Hey, Ian." Ah, yeah, great. Ian said, "Hey, Kyle." You didn't know this was going to be interactive. You thought you were just going to be sitting back. The Yoders, "Hey, Kyle." Hey, Rosemary, "Hey, Ian." Oh, great. We should have like had a bet on who would get the most hays here. Awesome.
I say you.
If you have any type of question, feel free to just say, "Hey, Ian," "Hey, Kyle." We'll stop and turn to you so that you can ask your question. We are going to be looking at ways of telling time, ways of finding your place in the universe. We're going to be using Egypt as kind of a topic for that.
Aren't they the same? No.
But we have a very special guest I'm actually going to introduce right now. And at the end of the program, I'm going to turn it over to Dr. Omar. He is he runs the planetarium at the Library of Alexandria. And if you don't realize, it's 3:30 in the morning his time right now. Dr. Omar, would you like to say anything?
Yeah, I'd like to say hello, everybody, and good morning or good afternoon. I don't know about your time now. My name is Omar Fikri. I am working, I'm planetarian for more than 30 years. I was starting for the planetarium field in Kuwait City, differently in Kuwait Science Club. It was a small planetarium, about 70 seats, with an old Spitz system. And I am working in the Library of Alexandria from the beginning. My contract at the Library of Alexandria is #1. And I know Kyle, and I would like to thank you, Kyle, for this invitation. I like to talk with him about the Egyptian sky and this nice topic about the sky and my country, Egypt. And I'd like to also to excuse me about my poor English, because it's not my. So I'll try to be clear and be slowly to understand my contribution for this nice meeting.
Shukran, shukran. In Arabic, I pretty much know how to say thank you and hello. So your English is actually probably better than my English. I really, really appreciate your time coming here. Yeah, let's get rolling here. So I'm actually going to be taking a trip to Egypt just in a couple of weeks, and I hope to come and visit you, inshallah, as they say.
Of course. A pleasure.
So I hope so. I hope so. Yeah, so one of the things that every culture that I know about has done is look to the cosmos to try to find out their place. So looking at how things are moving along, looking at the sky to trying to find out their place in the cosmos. I remember the first time that I actually noticed the stars moving at night. You know, during the day it's obvious. We start out with the sun over in the east, and later on it's over in the west. And at night it's a little more subtle. So Ian, have you had experience with that yourself?
I actually have. The very first time I ever looked through a telescope, we actually got to see the stars, and I can actually zoom in here. And so, yeah, the very first time I ever looked at the stars in a telescope, you could see them moving. And because your field of view is so narrow, you just see them moving across so quickly, and you really get the sense that Earth is actually moving. And it's subtle if you don't see it at first, but as you just watch for a little while, you can tell there's the horizon.
Yeah. Yeah, it's one of those things of, I suppose if you look at a clock long enough, you'd probably notice that the hour hands are moving. If you take the time and slow down enough to notice those types of movements. There's only been a few times in my life where I've really noticed that. If you're going to look at how the entire sky is moving, which maybe we can do here. We have a feature called time lapse. It'd be kind of like you go outside and you have a camera and put on the time lapse, and so you can record motions. Letting a few more people in from the waiting room here who are joining late. If you look at this image in Ian's sky, you can see that there's stars farther away from the pole seem to be moving farther, longer, and maybe we could try recentering this and see if we can find our pole star.
Let's find that.
Now, if you go to any planetarium show, they'll probably show you how to use the Big Dipper to point to the pole star, but we're going to try a little bit different method here.
Let's try that. There we go.
There we go. We're doing some complicated things here. Actually, Ian and I are connected, so he's controlling both planetariums at once. That's the thing about live shows is, well, they're live. Words and all. Yeah.
But from this perspective, you can see all the stars are moving around as the Earth is. What is the Earth doing?
Well, I've got a little model here. As the Earth is rotating, spinning around its axis, we of course are stuck on one part of the Earth. So to us, it's looking like everything is moving around us. Now I can see that the pole star seems to be about here. Does that give us any other information, Ian?
Well, a lot of information.
Okay.
Let's pause that for a second. Okay, there we go. There we go. So now, if we look at, say, that line right there, that line we call our meridian. And so the very top of the sky would be 90. And way there at the horizon would be 0. And we can see the angle there is about, what number is that? Folks at home, what number is that? What do you see in the chat?
Let's see here.
Can you see the number in the chat?
So the meridian line, this is one of these things that you actually use all the time when the sun is here. Let's shut off the tracers there, Ian. Yeah, and then speed up time so we can watch just the Earth rotate without those tracers.
Getting into morning.
All right. So Antes meridian is when the sun is before the meridian, AM. Let's go a little faster here. And when the sun reaches your meridian, would be your local noon.
Yeah.
And then when the sun is past the meridian, it's post meridian PM. So this is a really important marker that you can use. And when Ian was looking, showing the pole star, the rotation, it looked like that pole was located about 30 degrees from the horizon. So about here-ish. There. So you can actually use finding out, watching the stars very carefully will help tell you your place on the planet. This the photo that you saw, I actually took in Cairo in Giza, at the Giza Plateau, which is about 30 degrees north latitude. So you can use the stars to tell where you are on the planet. Now, the ancient Egyptians had different ways of measuring their place, measuring stars. They had different tools that they would use in order to measure the angles that the stars would be from the horizon. Now, you might not be walking around with these tools yourself, or maybe you are. I don't know. Ian, are there any tools, any suggestions you could give us on how we can measure the distances from?
Actually, yes. So let's see, do we have the speaker view on? There we go. So what you can do is you actually probably have two of them, your hands. So if you hold out your hands directly in front of you at arm's length, so they're proportional, what you can do is actually you only need one arm. So if you hold up your fist and hold it directly in front of you, all right, folks at home, you can do it. All right, so hold it directly in front of you, straight out, so it's like at your chin. How many hands will it take? How many fists will it take to get from directly in front of you to directly above you? Let's count. Ready? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 to get directly above you from 0 to, would that be 100 up there? So be 90 actually, because that is 90 degrees. So if it takes 9 fists to get from your horizon to your zenith directly above you, that means your fist is going to be about how many degrees? 10 degrees.
Yeah.
Yeah.
And so you can get a little bit more precise than that. Let's spotlight you, Kyle. You can see that 3 fingers is going to be about 5 degrees. Fist is about 10 degrees. Stretching out kind of Spider-Man style would be about 15. And if you really want to stretch it out all the way from pinky to thumb, all the way outstretched, that's going to be about 25 degrees. So you have a sextant on your hand at all times.
Nice. How many of you were able to print out that star map that I sent out? So if you have, hold up that star map so we can see you. Okay, awesome. What the star map has is a way of telling where the stars would be at a specific latitude and at a specific time. So this star map was made for the vernal equinox, about 8 p.m. in the latitude of Cairo. So if you look at the map, the area way up here, this is the pole star. So this is going to be the northern part of the sky. And you can see that that is about 30 degrees away from the horizon. The horizon is the entire circle. So I'm going to... Almost, yeah, I know. So the horizon is going to be all along the circle there. And if you look along the horizon, you're going to see some numbers. So like Ian was saying, there's 90 degrees in a right angle. There are 4 90-degree right angles along the horizon.
But also,
yeah, go ahead.
Also, we call the horizons the connections between Earth and sky.
Nice.
They're connected between Earth and sky.
Yeah, it's like there's where the separation line is between what's here and what's above. Yeah. In order to use one of these maps in the real world, it's different than a road map. You don't hold it between yourself and the road. You might hold it between yourself and the sky. Or your arms are going to get tired if you're holding up the sky map like this all night long. So I'm going to show you another way that you can use this. You face a certain direction, like let's say you're facing east, then you rotate the map so that east is down at your belly. And you're going to be looking at the distance that these groups of stars would be from the horizon. The area directly over your head is the zenith, and that's this circle right here. So let me pick a group of stars here. Let's say that I want to look at a group of stars that is, say, about 120 degrees along the horizon. So that's between east and southeast. So you're going to rotate your map so that 120 is about at your belly. And the group of stars that I'm looking at is actually very long. It goes probably from about 0 to 70 degrees toward the zenith. So type in the chat what you think that one looks like to you. So you can use this map, gives you an idea of finding stars. Now this map is set just for a particular time and a particular place on the planet. So it would be different if you're in a different part of the world and at a different time.
We have crocodile in the chat.
Crocodile, excellent. Yes. Excellent. All right. Let's see. Let's move on here a little bit. So besides telling where you are on the planet, you can also use the stars to show the passage of time. We did that a little bit earlier. There's a group of stars pretty famous in North America. We call it the Big Dipper. In England, they call it the Plough. And in Egypt, it's referred to as
the bull's foreleg.
Yeah. Omar, do you have anything you want to say about this particular constellation? Because I don't know any story behind this.
Yeah, if you heard about the story about Isis and Osiris.
Yeah.
It was an ancient and Egyptian story about man and woman. The man is called Osiris and the woman is called Isis. And there are a bad brother for Osiris called Set. And because of some bad feeling between these two brothers, Set killed his brother Osiris and cut her body and distribute each part of her body on the River Nile, old River Nile. And the mission of her wife after that to connect all parts of the body and again and to be live again this is about this is mythology of the Isis and Osiris, and the Big Dipper in the ancient Egyptian culture is called the leg of Set itself, because you can see some drawing on the symbol temple, the kind of comparison between the Big Dipper and the leg of Set. It's something like a leg of Paul, but in the story of Isis and Osiris is the leg of Set, the bad brother of gentleman Osiris.
Interesting. So even this one has different stories associated with that same.
Yeah, you can find this story in you can find this story drawing on the drawing of the Abu Simbel temple, the story of Isis and Osiris and the two brothers, Osiris and his brother Set.
So what I'm noticing here too is, and I'm going to switch back the view to Ian's screen, is you can use this group of stars as the Earth is rotating to kind of tell time, the passage of time, right?
Yeah.
So, Ian, if you put on the
but during my simple presentation, I would like to also share with you the Egyptians picked up the pole star to the brilliant star of bright star in the Little Dipper, not Big Dipper, and this was from a hole from the big pyramids, from pyramids, Khufu pyramids, the largest pyramid in Giza. And there are some hole in the pyramid itself, directly to the room of the king. And from this room, you can see the pole star. That was at the time of building the Giza pyramid itself. But now, because some orientation and the astronomical phenomena called the precession and the rotation, all these stories, it changed now.
Yeah.
I can show that.
Let's give you a reason about the old and new signs, zodiac signs. So the Egyptian make some calculations at the time of building 3 Giza pyramids.
Yeah, you were talking about, of course, in current times, Polaris is the current pole star, and I think we can show it here. Let's go back in time to the pyramids were built about 2500 BC, right, Omar?
2060 years, 600 years.
2600. Okay, so let's do this. We're going to change time right now to 2600 BC.
Yeah. At that time, you can.
The circle here, this is Polaris. Now, if we speed up time, we can see that 2600 years ago, Polaris. Whoops. Let me stop. I'm gonna no longer be controlled by Ian.
All right, your turn.
All right. There we go. So I'm going to speed up time here. That in 2600 BC, Polaris was not the pole star. The axis of the Earth was not aimed in that direction, and we could probably highlight this here with the time lapse. And there's a different star right here that at the time of the building of the pyramids, that was the pole star.
Yeah. That's because of as I said, because of the Earth's axis rotates something like the spin, which is called in astronomy precession.
Yeah.
If you playing with the spin, small toy for the kids.
Yeah, in English we call that a top. when you spin.
Yeah. This, at the end of the rotation, it will make an something slowly spin. This spin is called in astronomy precession. So the Earth's axis also makes this precession. The duration is 25,000 and some part of years. So at ancient Egyptians, when they built the Giza pyramids, the northern the pole of the star is not Big Dipper or Little Dipper. It's a very bright star in constellation called Thauban or Thauban. But this is also describe or give us description about why the new zodiac signs, also because of this the same phenomenon, which is called precession.
So something I was curious about, Dr. Omar, is in addition to, I mean, they can use the pole star to tell where they are on the planet. Were they also looking at when different stars were rising during the year?
You know, all of us doubt about ancient Egyptian. Maybe they have new technology at that time. Yeah, because when you see the alignment of some building like the Giza or Abu Simbel, if you hear about Abu Simbel, and I think that you also visit Abu Simbel and see the sun goes directly to the room of the king and his family twice, 2 times in a year. This comes from the observation of the sky many times and many years. Uh, Without anything, without any telescopes, without any navigation, without any planetarium or so you have to think how they do that, how they make alignment of this building to make the sun or to let the sun go enter this door or this room about 60 feet deep in this building to arise to let the sun go directly at the face of the king and then slowly moving to the face of his wife and to 2 kids and the bad man shadow, so the sun not go to the bad man beside the king. So when we make an interpretation about how they did build this big building from more than 3,000 years without any technology which we have now. So you have to, it's amazing for observation of the sky, not only the stars, but the sun orientation and also the moon. And I can give you, this one, this one. From right to left, the Akhenaton and his wife and 2 kids and the Batman in the left far away of left side of this hole, so the sun don't bright on his face. So there are some miracle about the building itself and how we can build such a building like this now using satellites and using observation and using some calculation and also using your mobile in your hand. You can use your mobile to build a building like that. Just go to the coordinates and make the alignment and write a line on the land. Okay, build here, for example, for your birthday. So you can make the sun visit your bedroom twice or 1 time a year. And also you can let the sun rise on your bedroom at the date of your marriage, for example, or birthday of your daughter or your wife.
And
so it's very easy now.
This and make massive buildings, be so sure in their calculations that they would build these huge buildings. And me as a modern human, I can't drive down to downtown without using my navigation on my phone. Right?
Okay. Also know the story about transforming a possible building in 1970, maybe example 1960, because the flood of Nile, and they transferring the building with the same orientation.
I can defend here a little bit. So this is the current position of the Nile River.
Yeah.
The reason that it's there is the Aswan Dam was built to control the floods, but it flooded this area, and these temples, this complex would have been underwater. So they moved it block by block to higher ground. It's amazing. So
also you can describe the story about Sirius star. Sirius star is very important for Egyptians. It's the time now. It's rising. Is the time now. Sirius. If you can show us the Sirius in constellations.
Yeah. Yeah. So we'll
the big Cancer Major.
Yeah.
Alpha Cancer Major.
I'll just look up. We'll just grab Sirius. And on your star map that I had people print out, Sirius is located right on the meridian.
Yeah.
So that's why it shows that time.
At south direction.
Yeah.
The ancient Egyptians was describing and counting how many days the Nile River will be flowed when the first rising of the Sirius. We can count 71 days, and then we can expect or make a prediction for the flood of River Nile. So they use one stars to make a prediction for the big event like the flood of River Nile. This event is called helical rising. Helical because when the star at rising time, when you observe the star at the horizon, you can see it is very reddish. The reddish, so it's called the helical rising because it's approached to be red color. The helical rising for the Sirius star.
So it's when you're saying when it's rising relative to the sun, then, right? Like
yeah, directly before the sun rising, and then when you see the Sirius for the first time, you can count 71 days, and you can make a prediction for the river flood of Nile.
I know that in looking at really deep details of when stars would rise throughout the year was very important. Even in, didn't they make some type of a chart that showed when different stars would be rising during different times of year? And my understanding is that these charts were so important that they even put them into the tombs of people.
You mean at ancient Egyptians or now?
Oh, ancient Egyptians.
Ancient Egyptians, if you heard about Dendera temple, Dendera, one of the very famous temple in Egypt, you can find some kind of at the roof of building a big sky. It look like the sky chart with you sharing with your audience. If you write the Dendera roof of Dendera temple, you can find it now. The Dendera make constellations about zodiac, old zodiac constellations, and which is very accurate according to the four directions: north, south, east, and west. So how they do that? They in two ways. One of them is, as you said, the River Nile, the alignment of the River Nile, and the other is the solar alignment. They make a comparison between the solar and the stellar alignment to make a prediction for all stars in the four directions. It's very complicated to describe now, but it is when you have a look for the roof of Dendera temple, you can find the accuracy of plotting the constellations.
I put a link in the chat to Dr. Rob Cockcroft's research on that. So if people want to click on that at some point, that'll get you some more details about those specific stars that they were looking at. And
that's the Zoom link, Kyle.
What's that?
That's the Zoom link.
Oh. Okay. There, yeah, sorry. Thank you, Ian. Let me try that again. There, that might be a little bit better. When you're talking about helical rising, I think we can demonstrate that here too, Dr. Omar. I'm going to put on the constellations as at least as we're showing them, and of course this is we're looking at things that, you know, a culture from over 5,000 years ago. So I don't know exactly how accurate this is, but the concept is going to be the same. I'm going to put the sun here on the meridian, and then we can zoom in. Let me just select our sun here a little bit. So we can zoom in, and we can show as the Earth is going around the sun, the stars that are behind the sun from our perspective will change over the year. So we could skip ahead. I'm going to just go a day at a time here. So as though you're out at local noon when the sun is on the meridian, and then you're skipping ahead a day at a time, and you can see that there are different star patterns that would be rising just before the sun.
Yeah.
And we can even, I loved what you said about they would use these calendars. It's incredibly important to be able to predict when the Nile would flood, since so much of ancient Egyptian life was really determined by that. So we can actually fly away from the Earth here.
Yeah, nice.
And look back at the Nile. Where we were located, I mentioned the Aswan Dam. So you can see down here where suddenly the Nile is fat and flooded. So there's a location of the dam right there.
Excellent, amazing.
And then we can fly away and see the entire Nile Delta. Let's go the correct direction here. And if you go out your window and wave, we'll be able to see you right here, Dr. Omar.
Yeah, Alexandria.
So what I could do is we'll fly away. So you can see our planetarium sun right up here. And I'm going to get a little farther away from the Earth and kind of change our perspective here so that you can see from the Earth's perspective the relationship of the Earth to the sun. And we'll do the same thing I was doing earlier, is skipping ahead a day at a time. And it's going to look like the sun is going along this line.
What's that line?
Okay, we'll put that up. So the ecliptic line, and in modern days, zodiac signs are going to be along there. But I was just fascinated by maybe during this time of year, that constellation, the prow, the very first part of that boat would be showing up above the horizon just before sunrise. And of course, this is because of the orbit of the Earth. Let's get the Earth's orbit here. So as the Earth is orbiting around the sun, then the constellations from our perspective will seem to change. So you can use the stars as seasonal markers. I want to show one thing, and then I want to turn it over to you completely so that you can show the alignments that you were talking to me about earlier, how the cities were aligned with the stars specifically. But I just want to get this one concept in first. Is right here, this is our entire solar system as seen from fairly deep in space. We're about a quarter of a light year away. And you can see that all of the planets are lost in the glow of that star. And you look at all of these other stars that we see in the Milky Way, and each one of them could have planets. Maybe there's some kind of civilization on one of these planets that are trying to figure out where they are in the cosmos. They have no idea that we exist. We have no idea that they exist. I don't know. And then we'll fly out far enough that you can see which stars are closer to us.
Wow.
Yeah.
We go far away now.
You're gonna go far away. And this again is way faster than any human, any technology we have, even faster than the speed of light. So this is the speed of imagination, maybe. But just the idea of how many galaxy or how many stars there are, but hundreds of millions just in our galaxy, and then hundreds of billions of other galaxies, and there's probably more stars in the universe than we have grains of sand in Egypt, which is saying a lot. And I'll fly us back home. I think, you know, the work that Ian does and I do and you do is so important because it gives people a different perspective that a lot might not have. You know, you look at what's happening in the world politically, how many wars are happening right now, and I really do believe that if we understood our place in the cosmos, there'd be less of that. And I'll fly back here to our planet. Yeah. And come back to your home over here in Egypt.
Yeah.
And then we'll land back in land back home, I guess.
Again, nice.
Oh, thank you. Thank you. I'm going to turn it completely over to you. And I'm going to be monitoring the chat. So if anyone wants to ask questions, and oh, is that outside the heliopause? Sorry, the Moffats, I didn't have chat up while I was flying. Yes. So that first place that we were at was showing the our solar system. That was probably about at where the heliopause, where the influence of the sun starts to be, I guess, less than the influence of other stars. Yeah, thank you. All right, so I'm going to turn it over completely to Dr. Omar, and I think you have some slides that you want to share too.
Yeah. Some slides with some stories also. Let me share my screen first. Yeah. Okay. Sorry for that. Okay. This is my desktop. Huh? Okay. Just a minute. Yeah.
There we go. You know, I do wish we could all be in the same planetarium right now, but the one nice thing about these Zoom shows is
yeah. This was the slides for my planetarium. This is a building of the library of Alexandria, and this is our planetarium. Also, there are a story behind the design of the planetarium and the story behind the color at night for the planetarium. I can share with you these stories. But concerning to the Egyptian sky, this was an article about the most ancient Egyptian, ancient observatory in the world. It was called Nabtablaya. Nabtablaya, it was far south of Aswan. Aswan is about 1,000 kilometers away from Alexandria. They put some stones there to make an observation for the galaxy and for Sirius and for the solar alignment at what is called solstice. Solstice means the date at which season change from summer to autumn and or from spring to summer, and the date for this change is called solstice. In astronomy, it is means some points on the sky when the sun moved on. It's called solstice. So this building, which is called Nabta Playa, and I can share with you the article. Nabta Playa describe how for more than 7,000 year BC, they building this most ancient observatory in the world, and the government of Egypt make its placement of these stones and put it in Aswan Museum, and anybody of your kind can visit Egypt, they can see this observatory. This is the first story about the most ancient Egyptian observatory. And of course, they not put these stones arbitrarily. They put it according to some observation of the sky and observation of the alignment of the galaxy itself. So in these articles, you can read about, you can make when and from where the galaxy will be rising, because the Milky Way rising from different places on the sky, or from the horizon. I mean different orientation of the galaxy. If you can, Kyle can show us the rising of galaxy for different seasons. For example, rising of Milky Way from summer, different completely from spring, and so on. So you can make a prediction of rising of the Milky Way according to the stones of this called Nabta Playa Observatory. And this is the alignment of the stones, and one of them moved directly to the Big Dipper and North Pole at that time. It was also made according to the River Nile. So the Nabta Playa is here. And of course, the Egyptology and the pyramidology, there are more science, more stories about the pyramids. One of them come from the writer called Robert Boval. Robert Boval there are some alignment for the three Giza pyramids. If you make a line from the eastern side of Khufu, Khafra, and Mankara, and this alignment go directly to a place called Heliopolis. Heliopolis, at ancient Egyptian, was the capital of ancient Egypt. So this is not by chance. This is according to observation for the orientation of building itself, according also to the River of Nile.
And what was the distance there again, Dr. Omar?
Which one?
What was the distance from say Giza to Heliopolis?
About 40 to 45 kilometers.
So no, they couldn't see it. It was not a visual.
You can see now. You can see Heliopolis from Giza now, but this is taken by satellites, make the orientation and make the alignment and the measurements for the eastern edge for each one here, for this point and this point and this point, and when we make, and also east and west sides, and if you divide two lines, they come together as the Heliopolis point. Heliopolis was a capital. This means the Heliopolis was the building of the king at that time.
Yeah, and so what I was asking is, there's no way that they could visually see from Giza to the capital. They had to calculate this incredibly accurately, without satellites, without any way of visually lining it up.
It is something, some magic, And also another story, or the third story, is about the alignment according to the Orion belt. Orion constellation is very famous constellation for all astronomers, and also it's very bright in the sky during the winter time. If you measure the center position of three pyramids, and make a line between them, you can find amazing the same measurement of the Orion belt with accuracy or 1.5 error, yani shift error. Now, because it's the orientation and some geodesic movement, and here, if you, for example, if you make a line between these two stars, you can find this one is shifted for about 4 degrees. And also you make, if you,
not a straight line. Most people think of
not straight line completely. And also you make a line between the first two pyramids here, you can find the same shift with the same angle. How they do that? without observation of the sky, without telescope, without theodolite, or without measurement, or without GPS or sky chart like you, like, okay? Also, if we get to one of the most Egyptian, famous great pyramids, there are one of called sorry here. If you make make a triangle on the planet Earth, you can find the same dimension of what kilometer with it's equal to the same dimension of Giza pyramids, which is called the actual or golden ratio, 1.43,200 kilometer. This ratio is the same for building the Giza pyramids. So they haven't satellites to measure this area. But one of interpretation about this amazing miracle ratio is observing the sun from different places away from the Giza pyramids itself, and make some calculations to make this golden ratio. Also, when I said about the depreciation, if you remember the story about depreciation, if you measure the difference between two numbers, it will be the same. What about the red here is the sun at the Lion constellation, the sun at the Cancer constellations during all this period of time. If you make subtraction between any two numbers of the green row here, you can find the same issues. It's called 2160. Divides the precession, duration of precession, which is equal 25,920. If you divide this number by 12, which is the number of zodiac signs, you can find the same difference of changing zodiac time. So you can make a prediction for the how. We can make a prediction for the what about the next change of the zodiac signs using the ancient Egyptian calculations according to ancient drawing of the Dandara and some calculations for this for the Abu Simbel also temple, some what's called Bardia written by hieroglyphic to describe the ancient old constellation,
the ancient Egyptians understood about precession. The Mayans understood about precession. The ancient Egyptians figured out the diameter, the circumference of the Earth. What year was that?
Yeah, I know the Mayan and the all the Mexican city also make some kind of calculation about the precession, and this is miracle for our time now. How they make this complicated calculation about the movement for the long duration of time.
I have a question that's related to that. So why is it when Egypt knew the diameter of the Earth, why was it that Europe forgot? So I can't remember the difference in time before Europeans discovered the Earth is round, and even now I have conversations with students and I have to talk about how the Earth is round.
Kyle, till now there are some questions have no answer about the Egyptology and the pyramidology also. Last story is the alignment of the Sphinx. You heard about Sphinx itself, which is called Apple Hole. There are 2 times of the sun rising from the right shoulder, and after 6 months, the sun rising at the left shoulder. So this is a very miracle, and this is a very magic. Also, it's not famous like Abu Simbel, but when I was contributed was at that observation with my colleagues in Helwan Observatory in the fields, and we traveling to Giza pyramids at very morning to see the rising of the sun specifically at that date, and also we can see the rising here, the lower picture, directly at the right shoulder of Sphinx. And after 60 months, the sun rising at the left shoulder. So this is also back to the story of orientation. So you can do that for two buildings, Sphinx and the Great Pyramids. So you can make orientation not only for one building, and also you can make orientation for two buildings, one front another. So the sun comes from this side today, and they come from other side after 6 months. So you can divide the once a year or twice a year according to the play of or the game of orientation.
On the star map that I made, let me just throw this on there. I didn't talk about it, but we do have the tropic lines, and that would be similar. That would be showing the rising points and setting points of the sun. That's this line and this line up here. If you follow them to where they meet the horizon, that's showing where the sun would be rising and then setting on the summer solstice and then on the winter solstice. So you're saying that the Sphinx was built so that its shoulders, when lined up with the pyramids, wow, that's amazing. That's amazing.
These two pictures, if you make a comparison between these two pictures, you can find the interpretation of how the sun rising at the shoulder of Sphinx itself. This is the Sphinx, and this is the Leo constellation in the sky. To know how they do that, they make observation when the sun will be at the Leo constellations. So at the summertime, the sun rising at the right shoulder, and the springtime or the winter time, the sun rising at the left shoulder. That's come from observation of when the sun rising at constellation of Leo in summertime. And this is an article about the rising of two shoulders of Sphinx itself. And he sit down here and look like make an observation of the Leo constellations. And some articles also say the design of Sphinx come from the design of Leo constellations, which is the same because they observing the sky, and this is so the ancient Egyptians know this is called Leo constellations, and it's written also on the drawing as a Leo, a line also.
Yeah.
And here the alignment of the direction. The Sphinx is direction with the middle of the pyramids and with the Leo constellations. We talked about that with you, Kyle.
Yeah.
The Sphinx and the transferring the building block by block, with the story also of orientation using the sky. And we shared this one. Okay, one of the last amazing story about the ancient Egyptian sky is the Alexander the Great. When Alexander the Great went to Egypt and built Alexandria, some stories called it was the date of his birthday. The birthday of Alexander the Great, it was summertime. At summertime, they observing the Leo constellations also, and they make one straight in the middle of the ancient Alexandria, this one, to let all the people in Alexandria see the rising of Leo constellations from this direction. And this is not not magic story. This is according to observation. And I can send you, Kyle, the article or the paper which describe this one, how Alexander the Great make one street without any building, left and right, because anybody at this area can observe the rising of Leo constellation at the date of birth of Alexander the Great. So it is amazing also, and like the story of building Abu Simbel, like the story of orientation of pyramids, like the story of most of Egyptian temples. This was the article of the building Alexander the Great itself. Yeah. Last one is orientation of some films. This is a real paper. I was also contributed with my supervisor at master degrees. We studied 325 temples in Egypt, from Aswan to Minya to Asyut to Giza to most upper Egypt, and make when the sun rising at that temples, and make some calculation about the what is called orientation. We find two types of orientation, which is called solar orientation and the stellar orientation. The stellar mean according to the rising of the first star of Big Dipper.
Okay.
You believe that, Kyle? They make some, we find some temples, the orientation or the acts of the temple itself built when at a specific time you can observe from this door the first star of Big Dipper. Also, I can send you two paper for the orientation of Egyptian temple and for design Alexandria itself. And here's some part of this paper and the position of the temples itself. Okay, we make some analysis about that, and that was the last slide of my contribution, Kyle. And I'm ready for any questions, and I hope to be contribute in the same topic of your nice event, Egyptian sky, and how they using mentality, maybe using some simple measurement or some fingers or hands to measure the orientation. So Egyptology is very, very complicated science, and behind them is a lot of amazing stories like Isis and Osiris and like the orientation, as I said.
Thank you, Shokran. Shokran, thank you so much. I'm absolutely flabbergasted. When I thought about doing a show about Egypt's sky, just because I'm going to be visiting Egypt again, I realized, I guess my own ignorance of how important these stories are, even modern times, but especially for the people who were building the temples. And it's important to me as a planetarian to give voice to people who are actually from that culture, like you, to share your knowledge rather than me misfiltering things. So thank you so much. I'm very honored that you came and shared your time and your amazing expertise. Thank you, Shukran. I can't say it enough. Let me pull up the chat and see if anyone has questions. Ian already said thank you, Ian. If you have questions, please put them in the chat or raise your
Tina.
Yeah.
Hi. My question is, I've been reading Serpent in the Sky. It's blowing my mind. And I have in here a picture of Dendera, the roof. And I was just wondering if your map is basically a portion of what this would look like for today, like current, basically, of this. Is that kind of what's going on here?
Well, what I did is, so my map is pretty basic, but it is accurate. It's showing. Let me just pull it up here again so that we can talk about it. Rather than me trying to tell the stories behind the constellations, I wanted to show some very basic things and encourage you to go outside and make your own observations, your own connections with your own cosmos. And but also know that there are amazing books like you just pointed out that give you deep research that's still happening by people like Dr. Omar and Rob Cockcroft up at McMaster University. I don't know if that answers your question. This is a moment kind of frozen in time. When the stars would be aligned at this point was only if you're at the latitude of Egypt, so 30 degrees north latitude, and it's set for the vernal equinox about 8 p.m. Let me see if I can demonstrate this. So I'm going to put on the constellation lines here and get a little bit different view.
So that's what we'll see when we're there on that day.
Yeah.
Right.
So yeah.
Okay, great.
So I'm going to put on the lines. Make sure I've got the right culture up. I was playing along as Dr. Omar was talking, so I changed back to Western culture since he was referring to that. But I'm going to go back here to Egyptian culture, and I'm going to put on the lines and the artwork, and maybe we'll be able to see through. As the Earth is rotating, let's see, here's the lines. So as the Earth is rotating, the constellations are going to appear to be moving, right? So there's only going to be one time during that night that things will line up exactly right. Oh, I'm at the wrong latitude here. I'm down in Abu Simbel instead of up in. Yeah. So you have to be at the right latitude. You have to have the right time. And so it's got that map is a frozen moment. As the night progresses, the constellations are going to be moving across the sky.
Great. Thank you.
You're welcome. Oh, Dr. Omar, on this is making the Milky Way more apparent. So you were talking about alignment of the rising of the Milky Way during different times of year.
Yeah.
So,
one of the functions of Lapse Observatory is to predict rising of the Milky Way. The reason is why they need to know what the place of rising Milky Way, because they behind the old Lapse Observatory area to put the body of dead person at special time. So they predict if somebody died, they keep the body until the Milky Way come to this direction, and they put the body in that day. So there are some ancient religion, interpretation about why they predict the direction of Milky Way. If you make a first time play for your sky now or the planetarium, you can see the Milky Way. It's not fixed daily. It changes from time to time.
Yeah, this is this is in January at
your background now. It's from left to right, something like arc. If you 3 months, for example,
yeah,
at the same time.
Head to April.
I do it in
and then I can
or the same sky.
I can
or
even
the same sky.
Yeah, same sky, and I'm going to skip ahead a month at a time to show.
So yeah. So this orientation, they waiting a special date to put the body of the dead persons for the place behind the Lapse Observatory.
Very cool. I guess if you are mummifying somebody, then you can entomb them whenever you want. I never even thought about that. You don't have to get them in the ground immediately. You can wait for an auspicious time.
Yeah. The body already, the person is dead already, but they make some mummies, and keep the mummies until the orientation of the Milky Way come to this place. Yeah, it's very joking story about it.
I saw. I wish I could remember the name of it. When I visited last time in the Sinai, there was a place where there were a lot of burial chambers. Now these were just stone structures with stacked stones. I noticed that all of them were facing toward the west. The opening was facing toward the west, but they weren't perfectly west. They were a little bit north of west and a little bit south of west. And I wondered if maybe that indicated where the sun was setting when that person died, or there might be some other meaning. Because if they could build something like the pyramids about that same time, they knew what you were doing. It was purposeful.
Yeah, I can give you the interpretation about that. This is a building, as you said, directly to the west or slightly southwest.
Mhm.
but this is the head directly to the southwest. But her leg at east. That's mean for the rebirth again after the new life after, yeah. So the rebirth again, the sun come from his leg because the body is big oriented to east to west direction after the new life, or according to the ancient Egyptians, rebirth. They put all material with them in the dome, and when they rebirth again, it will come from the east direction to wake up and go to the head. Yeah.
Sorry, I think my wife just came home and the dogs are barking. I'm gonna mute for a second here until the okay, they stop barking. The joys of working from home, right?
The joy is back in your lives now.
Yeah, I hadn't thought about that. I figured there was some relationship to, it's unusual to have something lined up to the west. I'm sorry, to the to the west instead of the east. But you're right. Like they'd be standing up then, right, toward the rising sun.
Rebirth.
Rebirth. Yeah. Any other questions from people? I've been chatting a lot here. This is absolutely fascinating. There was when I was visiting in Kenya, there was a stone circle. This was up in Turkana, so very far north, South Sudan, and the stones. So this is fairly close to the equator, and the stones there seemed to be lined up east and west as well. And I wondered if that was depicting helical rising of certain stars, but maybe it was something about the change in position of the galaxy over the course of the year too. I'd never thought of that. Fascinating.
I'm trying to find the yeah.
I'm going to turn my Milky Way down because that unrealistic sky is bothering me. But I would love to partner with you and make the types of information that you have, put that into a planetarium where we can do live shows with all of the data together. Oh, Rosemary says, I'm sorry I left briefly. Were there any large or whole sky constellations? Was the Milky Way associated with a god or a goddess? So she's asking if there were, let's see if I got this right. Rosemary, you can go ahead and unmute so you can ask your question directly.
Yeah, sorry, I had some dog issues as well. And I know some of the cultures have constellations that span a very large region instead of more the size of the Western constellations we have. So I was just curious if, in addition to the ones that you've shown, there were actually stories associated with a large portion of the sky, and maybe also the Milky Way. I know you were talking about the importance of it. So that's what I was asking about.
Maybe on that you can even address the idea of even before the story of Osiris, the idea of the Earth and the sky being. Oops, let me let somebody in here. Actually, I'll let you just answer. If there's association with the entire sky to any type of deity, I think that's kind of what Rosemary was asking. And then Susan was asking if there were any dark sky constellations. And I think what Susan, you're talking about, if we're looking at the the areas of the Milky Way where you've got the dark areas of where dust and is blocking the light of other stars. That's what you're talking about, right? Okay, thanks for the thumbs up. Yeah, I love the idea of placing the remains of people based on where the Milky Way is. In Kenya, the Maasai talk about this being the river of the gods, and I think there's something and their beliefs about kind of the recycling of souls as well. And when you're in a dark sky area, when you're far away from city lights, it really does look like a flowing river going across the sky.
Nice.
Yeah. And
It is almost 4 a.m. for Dr. Omar as well.
Sorry?
Oh, Ian was reminding me, I keep asking you all these questions, and you've been up, you started this at 3:30 your time, and
It's 10 minutes to 5 now.
Sorry, 5 a.m.
yeah, maybe we should let you go and actually have some sleep, unless you're just going to drink some coffee and stay up.
Hey, you can see the planetary conjunction in the morning. We can show that off.
That's the time for the what is called the Fajr prayer now.
Oh,
we make a prayer 1 hour before sunrise. Yeah.
Yes.
So it is actually 1 hour 30 minutes before sunrising. Yeah.
Okay.
So,
I
have 10 minutes. Yeah, I have 10 minutes. Yeah.
You have 10 minutes. Okay. That's what you're checking. I see. You were looking.
Yeah, yeah.
I love, that's something I loved about being in Egypt and other countries like that, where that ritual and that sense of it's 5 times a day, right? Where you stop whatever you're doing and you go back to what's really important to you and you reconnect. I love that idea. I really do.
Also the time of prayer come from astronomical concepts. Yeah. Which one is 1 hour before sunrise? It's called Fajr or dawn time. Mm-hmm. The dawn time, that's directly when the sun will be at the zenith time. It's called transit of the sun. So the third one, when your shadow 2 times before, 2 times equal your shadow at that. If for example, if your soul 160 centimeter, when the shadow is times twice your soul, this is the third time. Directly at sunset, its fourth prayer was called al-Maghrib. Al-Maghrib means at sunset prayer. With the same duration of al-Fajr, 1 hour after the sun setting, is called al-Isha, which is the last one. So there are concepts from astronomical concept of these 5 times for the Muslims in general prayer. Yeah,
that's beautiful, and I love that your calendar is still tied to the actual lunar cycle and actual observing, and I really appreciate that. It's not just a symbol, a calendar that means more. You were going outside and actually living your life based on the things you can actually see. So thank you. And I know you need to get ready probably for.
I'm very honored for all of you, and very thank you, Kyle, and your audience. I'm very happy. I'm not terrible about the time doing some kind of these events, because I'm feeling enjoy. But I was prefer to be from my planetarium also to make presentation, but I don't know how we can manage this time from 3 planetariums. It's very difficult thing that, yeah, to using my system and your system, and then we can make a playing with the planetarium to show some interpretation about the celestial stories and celestial topics in the future, inshallah.
Inshallah, I would love that.
Yeah.
That'd make me very happy. So, shukran.
Thank you.
Thank you. Thank you so much. Okay.
Thank you so much, everybody, for coming out.
I'll unmute and let him know how much you appreciated his time. And
Thank you so much.
Thank you. Thanks very much.
Thank you very much, Dr.
Lovely.
Omar.
Thank you, Kyle.
Thank
Bye
you.
bye. Bye bye.
Goodbye.
Assalamu alaikum.
salam alaikum. Walaikum salam. Wow, that was awesome.
I think you can go ahead and stop the recording.
I'm going to stop recording.